This is lesson 5, geotrig, day 3. We're going to continue into part A and then move into part B. First thing, just to kind of recap, we talked about exponents, and if I remember correctly, we did talk about simplifying square roots. We said we go to the square root dance. That means you make a prime factorization tree, and then you circle them up, your partners, and let them go to the dance. And anybody who does not have a partner stays inside the square root. You guys remember that?
Yes.
Yeah.
Okay. So we're gonna re-demonstrate that in this problem here. But maybe before we get into this problem, as you can see, we have square roots. But now it's not just of a single number, it's square roots of a fraction. So I'm going to break this out on its own. The square root of 3/2, or the square root of 1.5. Now, what we need to do here is we need to realize or remember that square roots are just another way of saying exponents, right? A square root is what exponent? What power?
2.
Not 2.
What? The square root of negative.
Not negative 2.
Half.
A half. So, would you guys agree that this would be 3/2 to the power of 1/2?
Yes.
And if I had a power on a fraction, I could take the power and bring it to the top and to the bottom. So therefore it'd be 3 to the 1/2, 2 to the 1/2, right? You guys agree with that?
Yeah.
Which essentially is each one of them has its own square root. So if I want to take the square root in our problem here, the square root of a fraction, I don't need to go through all the steps over here. I can think of it as, wait a minute, a square root on a fraction, I can just square root the top and bottom. So is everybody following me on that's okay to do?
Yes.
Which is fantastic, because then maybe that could simplify to something nice. But unfortunately, square root of 3 and square root of 2 are not nice numbers. You guys agree with this?
Yes.
And there's one huge problem with this, is the fact that I don't like square roots in the bottom or denominator. So now I have to start thinking, what can I do to fractions that doesn't change it, but I can do? Am I allowed to add 1 to the bottom and add 1 to the top?
Yes.
Okay, let's think of this through. If I had 1/2, am I allowed to add 1 here and add 1 there? So 2 over 3 is the same thing as 1/2?
Yes.
No.
No.
No. Right? I can't add and I cannot subtract. The only recourse I have of working with fractions is not to add or subtract to the top and bottom, but multiply or divide. So this does not work out. I'm going to erase that. Okay? But that means I can multiply. Now think back to the days when we worked with our square roots. How or what number would get rid of a square root? 2 of them, right? Like a square root of something times a square root of itself. You guys remember that? Like square root of 2. Square root of 2. If I multiply it to another square root of 2, I end up with square root of 4, which is just 2. Does that make sense, guys? Okay. So that is my plan. Also, I'm hoping you guys remember that square root of 3 times the square root of 2 would just be the square root of 3 times 2, which is 6. So if they're the same root and I multiply them, I can multiply the numbers inside. If it's the same exact square root times itself, it's the square root squared, which means the square roots cancel, leaving me with what's inside. Okay. Going back up to our problem of square root of 3 over square root of 2 now again. What, because I don't like square roots in the bottom. On top, I'm fine with, but not the bottom. So to get rid of a square root of 2, I'm going to multiply it by square root of 2. But don't forget, what you do to the bottom, you have to do to the top. And so, on the bottom, square root of 2 times square root of 2 will actually become square root of 4, which is 2. Square root of 3 times square root of 2, square root of 6. That is rationalize. That's called rationalizing the denominator. Now there's more to that. We'll deal with that later, because there very well could be 1 plus the square root of 2 on the bottom. And we won't like that either, because we don't like square roots on the bottom. That's not answering our question, is it? Did that simplify that really long expression up there? No. That was one particular part. You're going to have to do that a couple times. So, please listen carefully as we go through the steps. Can I erase this now?
Yes.
Okay. Looking at our problem, I got 3 times the square root of 3 halves minus 4 times the square root of 2 thirds plus 2 times the square root of 24. I want that simplified. We will be able to simplify this down to 1 term. Not 3 terms added. 1 term. So, this is what I propose. First time going through the problem, break it up. Do you notice you have square roots on fractions?
Yes.
Take care of it. Do you also recognize that 3 would be really 3 over 1? If that's 3 over 1, the 3 goes to the top and the 1 goes to the bottom. So would you agree this would be 3 square root 3 all over the square root of 2? I broke the square root, top and bottom, and took the 3 to the top. We now have the same thing with minus 4 and negative 4 times. So that means it's going to be minus 4 square root of 2 over the square root of 3. And notice at this point, 2 is going to be left outside. Do I like the square root of 24? I can simplify it. Okay. So, guys, I'm going to break out, make a tree. Actually, Marty broke out. Marty, hope you're feeling better. Marty, feel better.
There is no way Marty's watching this video.
He's going to watch this video and he's going to comment because they're still recording. Okay.
This is a YouTube live.
We're live right now. Face reveal. Oh, wait. It doesn't have that function, guys. Okay.
Got 100 subs yet?
Wait, it's hearing you right
Okay.
now.
It's recording us right now. Okay. Guys,
Watch this video.
you all have to watch this video. Okay.
I'm watching this video.
24, guys. Guys, notice I broke out over here. I broke this out over here. We're going to find or make sure, listen, we're going to make sure that we can or can't break down 24 into something better. So 24 is 2 and 12. You can do 6 and 4 if you want. 2 and 6, 2 and 3. Okay? It doesn't matter, guys, how you make your tree, as long as you know where all your factors are. You need to know that even if I do 6 and 4, I will eventually have 2, 2, 2, 3. Do you guys agree with that?
Yes.
The factors of 2, 2, 2, 3 are going to be there no matter what. Okay. Now, before, when I was doing this, I told you guys to write them as 2, 2, 2, 3. And then circle them up. I'm being lazy today. Do you notice that all of my 2's are in a row and my 3's already there as well? So, how many groups do I have?
2.
1 group
Oh,
of
wait.
2's.
Yeah, that's what I meant.
So, when that 1 group of 2's leaves,
Okay.
it becomes a...
4.
No.
Square root of 4.
A square root of 4, which is
2.
2. So hence, I drop another 2 on the outside. Now, over here, the 2 and the 3 don't have partners, so they join back together at home and become square root of 6. Can you guys agree with this?
Yes.
So the square root of 24 really became, ignore the extra 2, 2 times the square root of 6. But since 2 is already on the outside, the 2 and the 2 will make a 4. That's the next line. I'm only taking it one step at a time. I'm trying to do a little bit of work at a time, not all at once, and not in my head. Okay. So, I'm looking at these, and now I have square roots in the denominators or the bottom, and I do not like that. So now I have to fix it. I'm going to change to a beautiful color of purple, and we're going to use this. How do I rationalize that first fraction? I'm going to multiply the top and bottom by square root of 2. Because that'll get rid of the square root of 2's on the bottom, yes? The next one I'm going to multiply by square root of 3, square root of 3. You guys agree?
Yeah.
Notice on the last part, which is now square root of 6, do I need to actually do anything?
No.
Because there's nothing in the basement, right? Okay. Square root of 2 times square root of 2 is 2.
Oh, wait.
The top, I have a 3. I have a square root of 3 and a square root of 2. Well, square root of 3 times square root of 2 is square root of 6. The 3 is on the outside, so I have 3 square root 6. Everybody with me?
Yes.
If you're not, you got to speak up. Minus, wait a minute, this one's over 3 because square root of 3 times square root of 3 is 3. And now we have square root of 2 times square root of 3. And that's times 4. Excuse me.
Bless you.
Wow. So 4 square root 6. Plus 2 times 2?
Oh, wait.
Square root 6. Now guys, you guys need to realize that, wait a minute, every single one of these terms has a square root of 6. They have a common term. The only thing is that they don't have a common denominator.
Oh.
Yeah.
So what?
So there's a common denominator between a 2, a 1, and a 3 is 6. So now I'm going to go change my color. I'll change to this beautiful color of blue.
Yeah.
2 gets to be multiplied to what to get 6?
3.
So 3 and a 3, right? What I do to the bottom, I do to the top.
Yes.
Next one is
2.
2.
6.
And the last one is 6. Now, last hour when I did this, I did not put them in front. I put them in the back. And so therefore, I think kids were starting to get mixed up because they thought I had to put the number inside the square root. You got to remember, those blue numbers on the top are outside the square root. So you multiply it to numbers that are outside, or the stuff in front, right? It's a slight difference. So, when I go to do this, you get 3 times 3, which is 9 square root 6 all over 6. Minus 8 square root 6 all over 6. Plus 24 square root 6 over 6. And now they all have a common denominator. So when I put them all together, they will be over 6. What's 9 of something minus 8 of something plus 24 of something?
It's 25.
25 of something, and that something they all had was square root of 6. Done.
Whoa. Pretty simple.
The next one, I think, is actually a little bit easier. You just need to remember that when you multiply square root times a square root, you can take the numbers and put them together inside. Yes? Also the fact that if you multiply square root of something to itself, it becomes the number that's the same, right? Square root of x times square root of x is x. Square root of 3 times square root of 3 is 3. Okay? The other thing here is that this is a binomial times a binomial. You have to use the 4-letter F word, FOIL. Okay? Now, this is what I don't want
More than 4 letters.
you to do. Do not do this. But, okay, good question. Why not? That is foiling, yes?
Yes.
But which one are you connecting first?
First.
Okay, first of all, does it really matter which one you connect first? No. As long as you make all the connections. But 2, you guys all stared at me going, I don't know. Here's a suggestion. Take them all out and do first. First times first, right? What is square root of 2 times 1? I go back in, draw the other arc. What is square root of 2 times square root of x?
Plus the square root of 2.
No, careful. It's square root of 2 times a negative square root of x. I said it wrong, but it's written up here.
Oh,
Negative.
Negative square root of 2x. Because I can put them in the side, yes?
yes. You think I had it right, you just said it wrong.
I did.
Trick.
1 times x
Is it plus x? Is the right way?
at x times negative square root of x.
Is negative.
Negative x square root of x.
Oh, okay.
Done. Or, I'm not done because I can combine like terms. Question. Bless you. Is a square root of 2 the same as a square root of 2x?
No.
Is it the same as x?
No.
And is it the square root of x times square root of x?
Yes.
So actually, if you think about these are all kind of different things, right?
Wait.
Yes?
Why isn't it the same as the square root of x? Negative 2x and square root of x.
So you want to put this one
Yeah.
and the last one.
Yes.
Because this one has an x times the square root of x. Technically, this would be x to the first power times x to the 1/2 power, which is x to the 3/2 power. There is no other ones that have x to the 3/2 power. Now the question is, why don't I leave it, guys, or simplify it this to that? Well, first of all, this is exponent form, this is radical form. And if you notice, this is a square root of an x cubed, because the 3 is on top. So this would be square root of x cubed. How many x's are in that x cubed? 3. How many does it take to go to the party? 2. So wouldn't two of the x's be taken out, leaving you with 1 inside? That's why you get this. Whoops. This. That's why these are the same. Oh, where are we? My bad. These two are the same. Or 3. All this whole line. It's all the same. But yeah, this is it. Don't do anything else. In that case, they're done. Doesn't always happen. There might be a common term in there someplace. Okay? Make sure you gather it up. Okay. You guys ready for this now? Complex numbers.
Why is there McDonald's fries on there?
So,
Is that it then?
that was it for that.
McDonald's fries.
Okay. Not sure. I might have been hungry at the time. Okay. Now, complex numbers, ladies and gentlemen. I is equal to the square root of -1. Every time you've solved equations last year, we told you to solve for the real solutions because at some point you did the quadratic formula and you came up with the square root of -16. And you can't do that. Put it on your calculator. No real solutions. There's something called complex solutions. You guys got introduced to those last year. And so we're going to work with them some more. Now, if I square I have to square the other side. So I squared, and if I square a square root, They cancel, leaving me with negative 1. So anytime I see I squared, I can replace it with negative 1. We also have something called complex standard form. Complex standard form is a plus bi, where a is your real number and imaginary number is part b, not the I. The b is the imaginary part. Okay? A is the real part, b is the imaginary part. So, example, 4 minus 5i. That is a complex number. 4 is the real part, negative 5 is the imaginary part. What if I told you 3 is also a complex number? Or should I say 3 can be written in complex standard form?
3i.
How many i's are in 3?
1. Or 3.
Do you see any?
No.
So therefore, how many of them do you have?
0.
So if I ask you guys, listen, how many, or so say, if I ask you to take any real number and write it in complex standard form, it would be the real number plus 0i. Okay?
Got it, sir.
What this leads to, guys, is it leads to simplifying expressions with I to a higher power. This is like a 3, maybe 4-step process. Number 1, what does it mean to have I to the third power?
1.
It's I times I times I.
I think I just said that he was.
Negative 1.
Didn't
Now,
I? I think it was Marty.
I to the fifth would be I. Right?
Correct.
So, my first rule, my first step on these, expand it. Expand everything. 3, I. Plus 2. 1, 2, 3, 4, 5. Minus 3i. Plus 2i. Everybody could do that, right? Does everybody understand how I have that many particular i's at the time? Now, up above, it says that I squared, or I times I, is equal to negative 1. So what I'm going to do is I'm just going to go circle them up. That's I and an I. An I and an I makes negative 1.
Wait. What? Oh, no, yeah.
Moving on to the next group. I makes negative 1. I makes negative 1. There's a couple of different things. I'm going to put parentheses around that one. The next one, there's only one I. No, nothing to do there. And then the last two become negative 1. Notice all of this is still multiplied. I times I becomes a negative 1, but still multiplied to the other stuff. And now that I changed the i's or some of the i's to negative 1s, I'm just going to multiply. What's 3 times negative 1 times I?
Negative 3i.
Negative 3i. Negative 1 times negative 1 times 2 times I would be 2i.
3.
Minus 3i because nothing's done, right?
Correct.
And then I times I was at negative 1, so negative 1 times 2.
Negative 2.
And at this point, I'm down to numbers and numbers with I, right? They're multiplied. So gather up like terms. Take your real parts, put it first, because you got to put it in complex standard form. So, gathering like terms. Oh, wait. Negative 2 is the only real part here, right? Or something that's not attached to an I. So, negative 2. Then, the rest of these, I gather up. What's negative 3 plus 2 minus 3?
Minus 4.
Minus 4. So, it's minus 4I. Done.
That's easy.
Okay, so the next problem, guys, is that we have to simplify this expression. There's a lot of square roots. A lot of them are nice, like square root of 4, square root of 16. We can handle those really easily. Then there's other ones that have square roots of negative numbers. Remember, though, that when you're square rooting numbers, that you can separate into their own square roots, yes? So, remember, square root of negative 3. I'm just doing this for fun. This is a breakout for you guys to see this. Would you guys agree that this is square root of 3 times negative 1?
Yeah.
I mean, that is negative 3. But according to what we have been doing with square roots, they both can get their own house, can't they?
Right.
So that would be square root of 3 times square root of negative 1. Square root of 3, it's square root of 3. I can't simplify that. But square root of negative 1 becomes I. So this becomes square root of 3I. Notice that I purposely left a lot of space there. I is not inside the square root. Very important, okay? Now, this process, guys, of going from square root of negative 3 to square root of 3I is what I'm going to call, or say, poke an eye out. So when you see a square root of a negative number, I will let you poke an eye out, and then you can simplify the square root or the number that's there, that's left. Okay? That's a little bit of a breakout session. You guys ready to tackle the problem here?
Yes.
Okay. Okay, going up to our problem. The first thing you need to do is poke an eye out while you're simplifying. Notice we just did square root of negative 3. What did that become? Square root of 3I. And then, hey, might as well keep going to the right and say, hey, what's the square root of 4? 2. They're all multiplied. We'll clean that up later, guys. Can I simplify 3? No. What about square root of negative 2? What should that become?
2i.
Not
Square
2i.
root.
Square root of 2, and then an I on the outside. Square root of negative 9.
3i.
It's going to be poke an I out, so there's an I out there, right? But then you got the square root of 9, and square root of 9 is 3. So this would become 3I. Same thing with plus the square root of negative 16.
4i.
Yeah, does everybody see 4I?
Yes.
Square root of 16 is 4, and the negative, you poke an I out. Square root of 16?
4.
4. We're almost ready to simplify this. Now, remember the order. I like to put the order. Some books put I in between, or in between constants, or your coefficients and square roots. I like to still keep them at the back. I just make sure I don't put them inside the square root or inside the house, right? So I'm going to simplify things. My coefficients should be in front, though. So the very first one, to clean this up properly, should be 2 square root of 3I. Just kind of rearranged everything, right?
Yeah.
They're all still multiplied. What's the next one going to look like?
9 square root of 2i squared.
Okay, 9 square root of 2. Is everybody 3 times 3?
Yeah.
Square root of 2, can't do anything with. I'll leave it there. And then I'm not going to do I squared. I'll still do the I because I told you guys to break them down before, right? Can I do anything with 4I?
No.
So it's plus 4I and plus 4. Now I'll take care of my i's. Circle them up. They become what? -1. Angel? take a step back for a second. It's -1. In the large scheme of things, the only term that's going to change is which one? There's that middle one, right? So it's not going to be positive, it will be... Okay. Hey, look at that. There's actually no i's left attached to that. Plus 4I plus 4. Now all we have to do is group them up. But here's the thing. Some of them have i's, some of them do not. Therefore, when I group them up by like terms, you've got to put it into complex standard form. You got to put your real numbers first, the things with i's, your imaginary part second. So, looking on there, which ones do not have i's? The 4 and the 9 square root of 2, or the -9 square root of 2. Does the order really matter when adding and subtracting, or adding?
No.
No. So, I'm going to put the positive one first because it just looks nicer to me. 4 minus 9 square root of 2. That takes care of those two terms. The other two are both positive, so that really does not matter order, right? So then, therefore, plus 2 square root of 3I plus 4. I. What if I said you were almost done? Do you notice that it should be A plus BI? That's an I. Look at the last two terms. What do they both have? Can you take the I and put it on the back?
Yeah.
So therefore, it's going to equal 4 minus 9 square root of 2. I'll put parentheses around that because that's the A value. Plus 2 square root of 3 plus 4, and put an I in the back. So now you know A and you know B. No, no area of base in this one, guys. All right? So that is it. Here's your homework, guys. Oops, right there. Day 3, 11, 12, 15, and 16. Have a great day.